Okay, so welcome to our Astronomical Society of Penang APOD session for November 2022. APOD meaning Astronomical Picture of the Day by NASA. So we are hosting this at the end of every month for the past 2 years already. Okay, so tonight's session will be on November 2022. So we have our presenters here. I'm Dr. Chong from the Astronomical Society of Penang, and our society members is our Miss Boon Wei there. All right, Boon Wei from Penang, and our Mr. Rayan from KL, and Ku Yun Ning from KL also. Right, Yun Ning of course is originally from Penang. So we are presenting, and there is our young member also, Marcus Chung. Okay, he's from Penang also. Right. So basically, some of you in the world may not be familiar. So Penang is in the northwestern tip of the what they call Peninsular Malaysia. Right, so Malaysia, you have two parts: Peninsular Malaysia on the west and Sabah Sarawak on the east. So on the west is Peninsular Malaysia, and Penang Island, where we are now, is on the northwestern tip of the peninsula. So to the west of us would be Sumatra in Indonesia. To the north of us would be Phuket in Thailand. All right. For we are myself and Boon Wei and Marcus is in Penang, and Yun Ning and Riyadh is in KL, the capital city. All right. So that's where we are, and then we want to present for this month. Okay. So we start off by the first picture on the 27th of November 2022. I'll present. Can see, Boon Wei? Hello?
Yes.
Yeah, okay.
Yeah, I can see.
Okay, so we follow the flow. 2022 November 27. Supernumerary rainbows over New Jersey. I really like the title, you know. So basically, it's taken in 2018 by, we look at it first, then I go to my PowerPoint. There you are.
Wow.
So boys and girls,
many.
It's actually not really an fully astronomy related picture, right? But it's a rainbow, interesting type of rainbow, right? But you know that APOD mix a lot of things. So I call it a Rojak, a mixed website where you have physics, phenomena on the Earth, and then you have this astronomy, astrophysics, all kinds of phenomena. Pictures taken by amateur astronomers on the Earth's surface, or space telescope in space, or big telescope on the ground, or amateur astronomer. So this is taken in, I make it smaller, never mind, rainbow, by John Ernst Wiesel. It's actually a kind of amateur landscape, architecture, wildlife photographer. And he took it in 2018 after a certain Hurricane Florence that passed by. So for your information, New Jersey is a state just next to the New York. So very near to New York. So I'll show the PowerPoint presentation now. Okay. So 27 November, supernumerary rainbows over New Jersey. Supernumerary means like more than one rainbow over New Jersey in northeastern USA, just to the west of New York City. So that's the picture. Oh, you look at it, Boon Wei, so nice. So normally, have you seen before? When I've seen a lot of those, usually after the rain in Malaysia, let's say in the evening, the sun is in the west. So in the eastern sky, you can see rainbow. This is part of the rainbow. So it's actually a semicircular rainbow. But this is the part that is building up. So we have a bright rainbow, and you have the other rainbows. And this is explained by the fact that, later on I'll show you the website, that basically is that you have a lot of those water raindrops, the diameter of 1 millimeter diameter or less than 1 millimeter, and they're all of the same radius of the water droplet. You see this supernumerary rainbow. This is the main rainbow, and then you have this, and it's taken in New Jersey, right? So look at it. So this is another rainbow, the normal rainbow you see. Imagine that this is seeing in the eastern sky. The behind you is the west. So this is a guy here, and then you have the primary rainbow, and you see, look from the top is red, and then you have yellow, green, purple, blue. That's the normal rainbow, and this is the primary rainbow. And here on top of it, there's a secondary rainbow, but the order of the colors is reversed. You see, for this one, primary rainbow, from the top here, red, yellow, green, blue. But on top is opposite blue, green, yellow, red. All right. So so what we're seeing here is the primary rainbow. That's it. All right. And it's very interesting that you have many, many rainbows. Remember, this is seen according to the website. This supernovae rainbow prove that light has a wave nature. Remember, we know that light we learn in high school in the university that two types of nature of light. One is a particle nature, the photon. One is a wave nature, electromagnetic wave. So this shows the existence of electromagnetic wave for light. All right. So now this is the case. So now when you say what actually happened in the primary rainbow, let's say this rainbow here is what you look at this is the primary rainbow. It's like this. This is a primary rainbow. You see, you have a spherical water droplet, you have light coming in here, and light is actually reflected into the droplet. So outside is air, inside is water. Water has a refractive index of 1.3. So when it comes in, and we know that from the nature of light, when the higher frequency goes into the denser medium, it's reflected more, reflection, according to Snell's law. Right? So you see, blue is shorter wavelength, higher reflective index will be bend more. Red is less. So when it comes out here, you have blue is deviated more. This for the primary rainbow. So what happens in the primary rainbow? One reflection, Snell's law, and then you have here one total internal reflection, not Snell's law, just a normal mirror reflection principle. And this is a second reflection, Snell's law. And you see the primary rainbow. So here you see that the blue is deviated more than the red. For the second rainbow, it's like that. The light is not going from the top, go at the bottom, reflected upwards, and you have the blue one reflected more. So first Snell's reflection, and then for here, you have a total internal reflection here, first reflection, and a second total internal reflection, and then you have another reflection, Snell's law. And because of the fact that you have more, what you call one extra reflection, so more of the light is lost. And that's why you see that the second rainbow is dimmer. It's dimmer because of the fact that you have one more extra reflection, okay, for the east. And so this website I'll be following for so many days. The best website internet on atmosphere optics. Not too detailed, but detailed enough. So many phenomena on the Earth's surface, atmosphere, is explained here. Very nice. And this is the website. Okay. So this is the website we follow. So we are now going back to the today's picture, which is a supernumerary rainbow above New Jersey. Okay, you have a bright rainbow here, the first primary rainbow, and then you have the other rainbows. Okay, I can count here five of them, 5 rainbows here. So I pass over to Marcus. Marcus, your picture.
All right. Let me
Okay.
share my screen.
Okay, I'll share. Okay, you're on, Marcus.
Okay, y'all can see my screen, right?
Can see you, can hear you.
Okay, so the first picture I'll be presenting is the APOD of the 18th of November. So this is the L1527 nebula, and it's not just a nebula. In the center here, wait for the image to load. Right over here, there's actually a protostar over here, and this dark area is actually a disk surrounding the protostar, feeding it material. If a protostar is actually a star that is still in process of formation, it's still collecting materials from its surrounding environment, and the reason that the nebula is shaped like an hourglass is because the star is actually ejecting. The process of star formation is actually due to the materials from the process of star formation. And the proton star is actually quite young. It's actually only about 100,000 years old, which might sound very long, but it's actually pretty young in terms of the universe. Because like a lot of the universe is like 13 billion years old, and the star being only 100,000, that is very young in terms of universal objects. And this picture was actually taken using an NRI camera, which is a near infrared camera, which is taken by the James Webb Space Telescope. So this is actually a picture taken by the newly launched James Webb Space Telescope. And now for my next picture is the 20th of November APOD. So this was taken by an astrophotographer called Jeff Dye. He is located in China. You can go check him out over here. This is his Facebook information if you're interested in checking him out. And he took this picture in Tibet, which is actually a place in China. This whole area is called Tibet. And so these are actually not auroras. These are air glow. This is an air glow. So an air glow is basically a phenomenon that is caused by chemiluminescence, which is light emission due to a chemical reaction in the atmosphere. And this was actually caused by alternating air pressure within the atmosphere. And so this is, and to reiterate what I said, these are not auroras. They are two different things. And now, as for my last picture, it's a double star cluster in Perseus. There's actually a map here that shows you where exactly it is. This is the Perseus constellation, and you can find the double star clusters NGC 869 and 884 right over here. So these star clusters are actually both around 13 million years old, and because of their similar age, people actually think that they might have been formed from the same star forming region. So these are actually pretty close star clusters that are only a few hundred light years away from each other, and they have many stars that are younger and hotter, and they're much younger and hotter than the sun. And now I will pass it on to the next presenter.
Thank you, Marcus. Let me present my screen. Okay. Can my screen be seen?
Yes, can see, can hear.
On to the first APOD that I'll be presenting.
Wow.
Beautiful, beautiful image. This was taken on November 8th during the total lunar eclipse. In fact, the last total lunar eclipse for this year. The next one is going to be on Pi Day in 2025. Now, the person who took this, his name is Stan Honda. As you can see here, the credits and copyright have been given to him. Now, who is he? Well, he is a rather well-known photojournalist. He's currently working for AFP. For those of you who aren't familiar, that's the French international news agency. It was founded in 1835, making it, in fact, the world's oldest news agency. But Stan Honda, one of his most famous images was this of the Dust Lady. It was taken in the immediate aftermath of 9/11, about a woman who was completely covered in white dust from the collapse. Now, he's also an amateur astronomer, and being situated in New York, he decided to take this image in Manhattan. So what do we see here? Well, first of all, there is the moon. That's a very important part of the image because, as I said, this was taken during the total lunar eclipse. Now, you will see that reddish hue. That reddish hue is caused by the moon's position and the amount of air that the moon's light has to pass through, having to go both through the Earth's atmosphere. The sun's light has to pass through the Earth's atmosphere and then hit the moon and then bounce back through the Earth's atmosphere again before reaching our eyes or the camera, as was used in this case. So that causes that red hue. That it's the same. It's the scattering of light that causes the moon to look red. Now, this image here is a composite, and we'll get to that in a moment. I'd just like to cover the various pieces that we have in this image. First off, right next to the moon is, of course, the Empire State Building. It is 452 meters in height, making it just about 9 meters shy of our own Petronas Twin Towers. Now, right above the Empire State Building, in fact, seemingly in its line of sight, are the Pleiades, and they are a group of stars. And their name originates from Greek mythology. They were the daughters of Atlas, a titan who was burdened with carrying the earth on his shoulders as punishment. And the story goes, the Greeks did beautiful stories about how these stars got into the sky. So the story goes that the Pleiades and their mother went to visit Orion, the hunter. That's the same Orion that is referenced in this constellation here. And Orion took a liking to the mother and started chasing them, trying to get their affection for many years, until Zeus stepped in. Zeus, the king of gods, came in and turned all of them into doves. So they flew away from Orion, they flew high into the sky and became these stars. Now, one note, these are the same stars that give Subaru its logo. Now, you may realize the Pleiades, they are referred to as the seven sisters. There are 7 stars that constitute them. There were 7 daughters of Atlas. But Subaru only has 6 stars. It is the same constellation. The reason for that is because with the naked eye, we can only actually see 6 of the stars. So that's the same reason here on Subaru's logo, you can only see 6 stars. The reasoning that the Greeks gave was that one of the daughters was not comfortable.
Too shy?
Was too shy, because she was the only one who married a mortal man, not a god like the other sisters. So that's a little bit of Greek mythology for you. Anyways, the Pleiades stars are part of the larger constellation of Taurus, which we can see here. And that, together with the planet Mars right up here, are seen above this streak. Now, this streak is of the ISS. As I said, this was a composite image. And it's a composite of various exposures. Because the camera was left to take exposures for an extended period of time, the objects in the background can be seen moving. You can see Mars moving. The most obvious is actually the ISS. Each of these streaks is actually one exposure. To recount them, 1, 2, 3, 4, 5, 6, 7, all the way down to the end here, we get 16 total composite images, which was the number that Mr. Honda used for this image. Now, the reason you can see them so clearly is because they're moving faster and are much closer to the Earth compared to the other objects. They're moving faster relative to they're moving faster across the sky. And right below the streak, we have, as I mentioned before, Orion the Hunter and Sirius, the brightest star in the night sky. That's the APOD for November 12th. I shall now move on to my next, that of November 19th. Let me give my computer some time to load. Okay. Now, this is one giant of an image. So what do we have here? First of all, let's go through the credits quickly. This is by John Krause. He is a spaceflight photographer. And spaceflight is exactly what we see here. Well, what are we looking at? Well, at first glance, you see a rocket. This looks like a rocket, the booster, and the moon here. Now, no, when you take the image, you won't actually get a view such as this. This moon image was taken on the day of the launch, November 16th, during its waning, I believe it was the waning crescent phase, yes. And these little spikes that you see, let me zoom in very quickly. These little spikes that you see, they are caused by the pressure waves. They're caused by the pressure waves from the rocket, which changed the index of refraction around the air, which is why you get these spikes. But more importantly is the rocket itself. Artemis 1 moonshot. The name of the rocket is the Space Launch System, and this is the first time it was launched as part of the Artemis 1 mission. The Artemis series of missions are set to bring humans back to the moon after Apollo, and it's been a long time, yes. So let's talk a little bit about what this rocket has. Now, as you can see from this view, it looks almost as if these two boosters are providing all the thrust, whereas the main engines are not. That's not exactly true. 75% of the thrust is coming from these solid state boosters. Let me see if I can. There you go. So these are solid fuel boosters, and basically what that means is the moment you light them, they're not going to stop. You can't hold the fuel, unlike the core stage here, to stop it from firing for a while. You can't control it. The moment it fires, it's going. Now, these may look familiar. They are, in fact, the same design from the space shuttle. They're not the same, however. There is one additional segment. The space shuttle boosters had 4 segments. This one has 5. So it's not exactly the same, but it's the similar design. A lot of the parts were reused from shuttle because the history behind Artemis is a long political one that has to do with the Senate only agreeing to allow the rocket to be built if it allowed for jobs, for people to maintain jobs at NASA and such. So they had to reuse a lot of stuff from previous missions. But let's have a look at what we have here. As I said, we have these boosters. Once they are done, they can't be used anymore. They are dead weight, so they're ejected. There are explosive bolts that are used to attach them to the core stage. They are blown. Don't worry, the thing doesn't actually blow up into pieces. It just falls back to Earth. Then there's the core stage. That's what provides the rest of the thrust once the boosters are gone. And then you have the second stage. That's what's going to bring the whole capsule out of the orbit into the translunar injection. And then from there, it will eject, allowing the capsule to move on in its orbit around the moon. So what is so special about this capsule? The Orion spacecraft. Actually, I should have pulled up an image of it. Let's pull up an image of the Orion spacecraft. It looks very similar to Apollo, but it's about 50% bigger, and hence can hold about 4 to 6 passengers, whereas the original Apollo could only hold 3. So as you can see here, this is how Orion looks. Now this first test, Artemis 1, as I said, it's a test. So there were no humans on board. It was not a crewed flight. It is just to test that the system works. Artemis 2 will have humans. That's going to be launching in 2024, May of 2024. This diagram very quickly shows you what's going to happen during the mission. So they spend about 8 to 14 days heading towards the moon. As you can see, so this was how the rocket was. Pieces come apart, things are ejected, and then you're left with just the Orion spacecraft itself entering translunar injection. And then it's going to enter a distant retrograde orbit, distant because of its distance from the moon, and retrograde because it's going in the opposite direction of the spin of the moon. And what is supposed to happen, well, what is spectacular, besides it being a test, is that it's also going to be the furthest any human-rated spacecraft has ever traveled, passing the previous record of Apollo 13. So it's going to be going about over 400,000 kilometers away from the Earth, which is pretty far. Now the image, let's go back to the image. This image was taken on launch day, of course, but an image that we get to later was taken as we approach translunar injection. And Let's get to that image right now. APOD for November 23rd.
Yo. Great. I'm inside there. I'm inside there. All of us are inside there.
Yes, we are. Yes, we are. All 8 billion of us. Yes, the world population actually just reached 8 billion last week. All of us are in that tiny little circle. It's not a pale blue dot yet. It's not gone to Voyager distance, but all of us are on that planet. This image was taken during Earth set, you could call it, as the Earth was setting and was approaching behind the moon. And this is the view from Orion itself. This is the moon. This is the next place humans are going to. As I said, Artemis 2 will be May 2024. And while it will be human rated, no one's going to be landing on the moon yet. It's just going to orbit around, test the things out one last time, and then in 2025, hopefully, if nothing goes wrong, humans will be able to get back to the moon. This image here, as I said, it was taken on November 21st, the sixth day of the Artemis 1 mission. And oh yeah, this is what humans are going to be able to see some decades from now. Each and every one of you watching today may very well get to see this view in the future. And that all relies on Artemis getting there and on all the other spaceships getting there. So let's hope it all works out. I shall pass it back to the next presenter, which I believe is
Me.
Good way.
okay.
Yeah, okay. So I'm the next present. Let me share my screen first. Okay, so hi all everyone. Good evening. So I would like to talk about the 14 November APOD. So can you see my screen now?
Yes.
Okay, so this is the 14 November APOD. Very beautiful picture taken by Joanne Popper, an astrophotographer. So this is the NGC 7380, the Wizard Nebula. So the shape looks like the nebula, and I really like these orange colors in this picture. That's like a fire wizard. So actually, it's the interplay of the stars and the gas, the dust that actually created it like the a wizard head, I would say. So Yuan took this picture with using the narrowband filter. So actually this NGC 7380 is quite challenging to observe with the naked eyes. Usually will require a very, very dark sky and with also the filter. So if looking visually is the nebula size should be comparable to the moon, may probably is appear larger than the angular extent of the moon. Yeah, so to view this nebula or to take this beautiful picture, so using the narrowband filters, like what Yuan do is the best recommended. So because the emission nebula gas in this deep sky object is actually strong in the light wavelength of the hydrogen alpha and O3 band parts. So the narrowband filter is actually to use to the isolate and then to boost out all the details of the characteristic of the emission gas. So after combining all the data, especially in H alpha, because the NGC 7380 is rich in it, so you can see a very clear and colorful NGC the colorful wizard here. So this nebula was discovered by a German astronomer called Caroline Herschel in 1787. And after this, her brother William Herschel is included it in his catalog, something like H533.77, something the numbers. Then to actually where do you want to see, or where do you want to locate the Wizard Nebula is located in the constellation of Cepheus, also known as the King of Ethiopia. So the deep sky object is about 8,000 light years from Earth. Within the Milky Way galaxy, is actually located in the Perseus arm of the Milky Way, and the star cluster of the NGC 7380 is actually embedded deep within the nebula, and the age is quite young, just only formed like within the last 5 million years, but some of the stars in the star cluster is actually may form outlive our sun. So our sun is maybe still younger than them. So this is an active star forming region, spans around about 500 light years. The stars inside the NGC 7380 is so unleashing the powerful of the stellar winds, so making it this wizard shape that we could see. Yeah, so I'll go to the next APOD. My next APOD is on 11. So this is the blood moon and the ice giant, which is taken by the Ryan Han. I think should be the amateur astrophotographer from China. And as we all know already that the 8th of November there is a total lunar eclipse. And then actually on that day, there is also another event called the lunar occultation. So this is mean that the planet is going to hide, going behind of the moon. So it's actually happen, and this event can only happen at the certain place from the Northern America or part of Asia. So the very distant and the faint ice giant planet, the Uranus, will disappear from the night sky for a brief period in a short while when the moon passes in front of it. So in this picture, this taken by Ryan Han in China, Shanghai, on one rooftop. He actually captured this this picture just before the occultation of the Uranus began, using different telescopes. So a closer view and a further view. From this, you can see already with, so you can already see, you can already see a small dot here. This is our ice giant, Uranus, and then with this a closer up and a wider view with a tiny and pale greenish. This is actually just going behind the moon and is going to disappear. So actually the lunar occultation is quite common compared. It's actually happen, I think, every month. So but this is very very rare that it happens during the total lunar eclipse. Means that the planet Uranus had to be both at the opposition and very, very near to the ecliptic plate, and fall in line with the sun, earth, and moon, because total lunar eclipse happen when the sun and earth and the moon is in line. So the next lunar occultation of Uranus is actually will happen in the 5th of December during the full moon, but it also only can visible observable from certain area, but that date is no eclipse. So this event and this picture is very lucky and special. Yeah. Okay. So I go to my next APOD. Yeah, my next APOD is also a total lunar eclipse that happened on the 8th of November. So this APOD is taken by Peter Horelek at the Cape Peak National Observatory. So the observatory is under the program of the NSF Noy Lab in the institute under the Institute of Physics in Opava, Czech Republic. So this eclipse, the time of the total lunar eclipse is happen and lasts about 1 hour and 25 minutes, and the phase is start from the right and then finish to the left. And Peter took this timeless eclipse with using the ISO 640 and then 6-second exposure. So actually this is the video that taken by him. So you can see the moon is slowly goes from the left side to the right side. Yeah, so this is a time-lapse video. It shortened it into 19 seconds, but it's actually happened in 1 hour and 25 minutes long. And you can see at here this our total lunar eclipse happened. You can see it is the moon is in red because of our light scattering happen at the Earth dusty atmospheric, and then so the moon is shown in red, and then actually you can see a very, very like here there is a additional reddening. It's most likely because of the remaining dust the ash lingering in the atmosphere after a large volcanic eruption in the southern Pacific earlier this year in January. So it's called Hunga Tonga Hunga Hapai volcanic eruption. Yeah, so actually the eruption causes tsunami in certain place as well. So if you still remember that event, and yeah, so looking the right and the left side for the moon, you can see the Earth shore is still lighter along its edge, and then here there's a bluish fringe. Is actually because of is also because of the light scattering, the Rayleigh scattering, that when the sunlight passes through the Earth's atmosphere, then the red light is absorbed by the ozone compared to the blue light, and then yeah, that's why the blue is remain here. Yeah, that's all from my side. I pass to the next presenter.
Yunming?
Let me stop my screen. Present.
And I guess I'll start presenting now. Now I'll start presenting with the November 5th picture, which is a lunar eclipse at the South Pole by Aman Trotsky. Now the main features in this picture would be the composite image of the lunar eclipse,
Oh, yo.
which
Horizontal, huh? Interesting, horizontal.
yeah, yep, which is made of many individual pictures, and the aurora, which is the green band we can see in the picture. So lunar eclipses are formed when the moon is in the Earth's shadow, and this only happens when the sun, the Earth, and the moon are in a line. And in these cases, the moon is in a lunar node. So the formation of eclipses can be calculated using the Saros cycle, which is 18 years and 11 days long. Using this cycle, we can predict the times of the eclipses. And now onto the other interesting phenomenon, the aurora. Aurora form when charged particles from our magnetosphere of the Earth strike molecules of O2, which is oxygen, and N2, which is nitrogen, in the ionosphere, which is a layer in the Earth's atmosphere. So when the electrons from the magnetosphere, the charged particles, when they strike the O2 and N2 molecules, the O2 and N2 molecules are energized and ionized. And when they relax, they emit photons of unique colors, which then reach our eyes as lights of the aurora. So the lights we see here, they are actually photons of a specific color that form due to the relaxation of O2 and N2 that was ionized and energized earlier on. And the amazing thing about the photo is how these two relatively rare events can be seen at the same time. Another fact is that the aurora can only be seen at the higher latitudes. So there is about no way we can see aurora in the tropics where we are right now. So on to the next picture, of which I'll be presenting, the November 6th picture, which is by Jim Lafferty. So in this picture, we see a dark ball in a relatively whitish background. And the special thing about this dark ball is that it is a sun. How we get this picture from our typical picture of sun, which is an orangey yellow ball, is that we take a picture of the sun in a specific color, which is in a specific wavelength of light. In this case, it should be the hydrogen alpha line, which is 656.28 nanometers. That at the wavelength of light, the picture of the sun was taken, and then it was rendered into black and white. So, and then the color was inverted. So, as you can see, most of the sun is darker, and there are some spots that are either darker or lighter than the sun overall. The same color inversion technique was also held in the star field, which is the whitish space that surrounds the sun. And this star field, it reminds me of a certain scenario painted by the Olbers paradox, which states that in a infinite static homogeneous universe with infinite number of stars, the night sky will appear bright because all light from the stars will eventually reach the Earth, Well, we of course know that that's not the case. Our night sky is dark, and there's several reasons that solve this paradox, including the fact that the universe is finite and that the universe is expanding. So light from these stars might not have time to reach the Earth, and due to redshift, the light from these stars might have had their wavelengths increase, which makes them, I think, using the current wavelength, the current redshift number should be about microwaves now. And this star field, I think I can see a part of the Pleiades star cluster to the left of it, which Reagan mentioned earlier on. And so now we enter the other features of the sun, which are the black dots and the lines in white on the sun. Our sun is quite active, whether magnetically or in other forms. It's not just one plain ball in the sky, but it includes filaments, which look like prominences, and there are hot eruptions of gases. There are dark active regions, there are prominences, and of course the sunspots, I think, should be the dark the darker spots. I think there are sunspots, and in these phenomena, due to these phenomena, there's solar winds created, and when solar winds are created due to the eruption of gases from the sun, the solar winds would then reach the Earth, hit the Earth's magnetosphere, and cause the auroras we have seen earlier on in my previous picture. So now I'll go on to the November 8 picture, which shows 3 galaxies.
Wow.
And this picture is taken by Hubble, NASA, and other parties.
Wow.
So many.
Ya lor.
There's a tikus there. Tikus.
Tikus?
Yeah, the galaxy interacting. Look like the tail of the tikus. Mouse.
Ah.
So, main focus on the picture is that how the three main galaxies you can see are not next to each other, but are some distance from each other. So although these 3 galaxies look like they're next to each other, the third galaxy is much further away from the other 2. And this reminds me of a certain myth that stars in constellations or asterisms, stars that appear close together, are close to each other, which is mostly not the case. Although stars might have a small angular distance between them, but they might have a far radial distance. They might have very, very different radial distances from the Earth, such as in constellations like Ursa Major, or even Orion, as Ryan mentioned earlier on. Of course, the Pleiades, the 7-star cluster, that is an exception, where since all 7 members are relatively close to each other. So again, the main attraction of the picture is how the 2 galaxies here interact each other to form a bridge that's around 200,000 light years long. So this forms when the 2 galaxies that are on a collision path with each other, they will interact each other, and there is a gravitational pull of each other, and that causes streams of gas to form, and there is fading turbulence. So when galaxies travel towards each other, like how our Milky Way is traveling towards the Andromeda galaxy in maybe a few hundred million or billion years, the galaxies will merge with each other. So in this case, it's in about a billion years, these two galaxies will merge with each other to form a larger galaxy, and the same can be said for our Milky Way and the Andromeda, which is around 1.3 billion years from now, I'm not mistaken. Right, so I will pass it back to Dr. Chong.
Thank you, Yun Ming. So share my screen. Okay, so this is for our November 13. Okay, so very interesting title. Flying saucer crash lands in Utah desert. So this is taken by our United States Air Force 388 Range Squadron Genesis mission by NASA. Okay, so we look at it here now. Okay, so
That was a dead fish actually.
yeah, it's nothing to do with flying saucer. So these two helicopters is the United States Air Force landing in a desert in Utah. You know, Utah is somewhere in the central United States. The capital city is Salt Lake City. All right. So in this 2001, NASA did the Genesis mission. All right. Now you remember, Genesis means the creation, not the creation of the universe. In this case, creation of our solar system. So at NASA. So in the year 2001, NASA sent a mission called Genesis mission to collect the solar wind particles in space, near to the Earth in space. And then the thing is that the Genesis mission was from 2001, 2004. All right, collected a lot of data, solar wind particles. But then in landing, it crash landed. Normally crash landed means there must be a parachute, soft landing, but it was some last minute, some problem, crash landed and hit the Earth surface at 300 kilometers per hour. All right, so that it was damaged. So a lot of the samples are all contaminated. But you must understand, anything in space coming to the Earth is many kilometers per second. Let's say it comes down at 1 kilometer per second, it should be 3,600 kilometers per hour. So it's actually slowed down a lot by the parachute. But at the last moment, not enough slowing down. So it crashed, still a bit of velocity left, 300 kilometers per hour. But if the parachute doesn't open, when it hits the Earth at 10,000 kilometers per hour, everything is blown into powder. But then because of that 300 kilometers per hour, they were still able to recover. So what is this Genesis mission? Is this? So inside this, what you call Genesis mission, you have this collector, because a lot of those silicon and those hexagonal things to collect the solar wind. So basically like that. So you see on the left and right. So that they want to study, they assume that the outer atmosphere of the sun gives off what? Solar wind. What solar wind? Electrons, protons, and also ions. Ions means IONS. The heavy element, they have lost some electron. So these electron, protons, and ion come up from the sun. So they assume that the sun has been giving off this steady rate of solar wind for billions of years. No change at all. So if they were able to collect those solar wind particles using this Genesis mission with this collector, they will be able to study the original part of the solar system when the planets were forming. So if they were able to do that, so that was the whole idea. Collect the solar wind particle now, and if the sun's outer atmosphere do not change much over the past few billion years, it's effectively as collecting the material that form the planets in the origin of the solar system. So that's fantastic. All right. So the thing is, how was it done? They sent on the center of the sun, up to the right is the Earth, and you have the famous 5 Lagrangian points named after the Italian French scientist Lagrange. So you have L1 between the sun and the Earth, L2 beyond the Earth. Remember the recent James Webb Space Telescope was L2, but this Genesis was L1. Why L1 is closer to the sun? So sun from the Earth into the L1 point. So what are all these 5 Lagrangian points? 5 Lagrangian points is where the gravitational potential energy is more or less constant. So very stable. So if I put a spacecraft there, to the left and right it moves, more or less the same gravitational potential energy, so it's stable in that orbit. Whereas you put it near to the Earth's surface or near to the sun, the gravitational potential energy changes a lot. So that means the object will fall towards the sun. So in these 5 places, L1, L2, L3, L4, L5, the gravitational potential energy do not change much as you move left or right, up and down. Therefore, it's stable. So Genesis was sent into the L1 point and exposed to the sun for 4 years, 2001 to 2004. And then it tried to land back on the Earth, but in landing back on the Earth, the parachute didn't deploy at the last moment, didn't deploy well, so it was damaged. But then they were still able to recover. So basically, this is the orbit, so sent from orbit, and then finally it went into this. It's not only in the Lagrangian point, it went to the Lissaudieu figure, the so-called halo orbit around the L1 Lagrangian point. And here, exposed to the sun on the left, they collected all those particles, solar particles, solar wind particles, which is the electron, protons, and the ions that hit the Genesis collector, but in landing on the Earth, it didn't land well. So in landing back on the Earth, all right, so basically, now, this is a very important part of astronomy, you know? So a study of isotopic ratios. Now, we know that on the Earth's surface, every single element got isotope, you know, except even the sun, even the hydrogen, simplest element got isotope. One is, for example, in the center of the hydrogen atom, you have proton. Case number 1, and in case is proton and neutron, called it deuterium, right? Or a proton and 2 neutron called a tritium. So even the hydrogen also got isotope. So every single element got isotope. So in astronomy, this is a standard thing. Imagine you have a meteorite made of iron fall from the sky. And you also have a lump of iron in your motor car. So you study the iron from the meteorite and the iron from your motor car. The iron from the meteorite, maybe iron may have 8 isotopes. So by studying the abundance of different isotopes of iron in your meteorite and in your car, there are different ratios. You know a lot about difference of the iron in the meteorite and the iron in your car. So by studying the isotopic ratio of the solar wind particles, they will know a lot about the original state of how the solar system was formed billions of years ago. And even then, they were able to collect some of the undamaged, what they call samples from this crash, so-called flying saucer. They were able to get some data, all right? So this is the case. So basically, is that all kinds of interesting research they can do in astronomy. Okay. So now we go to the November the 9th, okay, which is the asymmetric nebula surrounding the Wolf-Rayet star 1810. And then, oh, so nice, you know. So basically, we know in astronomy that a Wolf-Rayet star is very important. So Wolf is named after one scientist, Rayet, another scientist. So Wolf-Rayet star. So they are very energetic stars. They give you a very powerful stellar wind. So this Wolf-Rayet star number 18, all right. So they found that what's interesting about this Wolf-Rayet star is that asymmetric. So the right side, you see that very bright. The left side not so bright. So it's in the constellation of Carina, okay. And from left to right in the picture is about 75 light years across. So when they first did it, got this picture, they thought that it could be the normal case of a Wolf-Rayet star. So Wolf-Rayet star is it give up very powerful stellar wind. You know. It's so powerful that imagine the Wolf-Rayet star, you cannot see it right in the center there. There's a star, all right. It gives off very powerful stellar wind, like the force of a hurricane. Imagine we are now in the Earth's distance from the sun, about 150 million kilometers from the sun. The solar wind has a certain pressure, but the solar wind's pressure is not so great. You are somewhere in this nebula. The force of the solar wind hitting the spacecraft maybe can blow the spacecraft out of its orbit. Very powerful stellar wind. So they thought that because the Wolf-Rayet star is not what they call stationary, it can move very fast in space. All right, move very fast in space, and when it moves, it creates a so-called bow shot. Bow shot meaning you're on a ship, And as the ship travels in the water, in front of the ship, it push the water aside. So that's called the bow shock. So they thought that as that star passes through the interstellar medium, so it creates the bow shock. But later on, the research said, no. It's actually that on the right side, the density of the material in the interstellar space is greater. And on the left side, the interstellar density is less. So that's why it's more invited here. And by the way, we know that for a lot of information we get, that the universe or our Milky Way is a very violent place. We know that, for example, there are cases of this neutron star is traveling far away from the Milky Way galaxy, is leaving the Milky Way galaxy. What happens is that when you have a supernova explode, that case like a great supergiant called Betelgeuse explode. So usually on the Earth, nothing is equal exactly. So when the supernova explode, one side of the explosion is more powerful than the other side. So what happens is the remaining neutron star that is created will be shot out from the one side. Let's say they thought that maybe there was an explosion earlier, so it shoot out say kind of, in this case it's not the neutron star, but after a supernova explosion, you can have a neutron star shooting out very fast, greater than the escape velocity of Milky Way. It can escape the Milky Way. So you can have stars shooting out from a certain object. But this case is not this is not a supernova explosion, just some what do you call this, a star, Wolf-Rayet star number 18, very powerful stellar wind that created this what do you call this, asymmetrical nebula. So basically, like when you have this stellar wind hit those particles or molecules in space, it can also energize this molecule. Energize molecule, that so basically the light and the particles ejected by the Wolf-Rayet star will excite those molecules or atom, and the molecules atom will be excited, and when they de-excite, will give the quantized nature of the energy levels of those molecules or atoms. So it shows that quantum mechanics. So when the light drops down, it's only discrete lines, not continuous line, discrete, and it gives those colors. Okay, so this is called the November 13. We go to the next one. November 9. No, November the 4th. No, wait a minute. Yes, the last one, November 4th. So this is inside final selfie. Now we have seen a lot of pictures now of many of our what they call spacecraft in space taking a selfie. Even the recent what they call Artemis mission also, in a sense, to take a picture of the spacecraft, the selfie with the Earth and the Moon in the background. So this is the one. So this is a NASA mission that was sent in I think 2018. So when this NASA mission called Mars Insight, all right, and this is a solar panel 2 meters across each, the solar cell, and this is it was a few years on Mars, but sometime this year when it's about to shut down its operation, it took a final selfie. Not a fantastic picture, but the meaning is important. Okay, so basically that you have this Mars Insight was landed on Mars a few years ago, and only this year it was stopped. The mission more or less terminated. So what is the Mars Insight mission objective? So basically it landed in a place called Elysium Planitia. So please learn your Martian geography, learn your lunar geography, learn your Mercury geography, learn your geography of Io, the moon of Jupiter. So we must learn about places in the solar system. Just like, have you been to London? Yes, I've been. Have you been to Kuantan? Yes. So have you been to Elysium? Do you know the place called Elysium Planitia? So this is our Martian geography. This is a place where Mars Insight landed, and basically it studied seismic investigation. So basically on Mars Insight lander, you have seismic detector, earthquake detector. So it detected 1,300 Mars quake, not earthquake, no, Mars quake. So you have a quake on Mars is Mars quake. A quake on the moon, moon quake lah. You have a quake on Io quake lah. So this is a Mars quake. So it shows that the interior of Mars is not dead. There's some kind of a volcanic activity, and so on. So geodesy is related to a lot of things about the Earth, the gravity, the gravitational field of the Mars, and so on. Okay, heat transport. So although the center of Mars is not completely dead, but it's not as alive as that for the Earth. Earth's heat transport is a lot in the center of the Earth. It's molten, nickel and iron. But there's still some heat generated in the center of Mars, so there's heat transport from the center to the surface of Mars. So that's basically that's what it's doing. So you can do a lot now. So basically, you go back to the Mars. Okay. So basically, maybe in this Mars Insight, there's a team of scientists, and one of them is doing geodesy. He will be getting a PhD on it. And the earthquake one, maybe 5 seismic scientists are working on it. 5 of them will get their PhD. So they're doing a lot of original research. Okay, so this is the Mars Insight lander, of course, by NASA JPL. Okay, JPL is our Jet Propulsion Laboratory. Yeah? Okay, so this is the case for APOD for 4th of November. Okay, so we go to the end of this presentation now. I go back to the okay. So before we see any question, any comment by any of you, I have some question on some of your presentation. Anyone? Ryan?
Nothing that I can think of right now.
Yeah. So my general comment is every single picture we presented, if we go deeper, a lot of science can be explained. A lot of science can be explained, and you explain it to the young people who are new to astronomy. They thought astronomy, astrophysics, cosmology is boring. Oh, the way he presented is so exciting. In a small picture, he can explain so many things: chemistry, physics, mathematics, so many. So everything is in. So actually, I would say that every of the single picture we presented, we can talk a lot about physics, what you call this, quantum mechanics, gravity, a lot. And somewhere there's a picture of a certain scientist. Well, you can talk about the scientist biography. A lot of things can be explained in a single picture. Okay. So any question, Michael? Anyone can see?
No, I also checked from Facebook and YouTube. No.
Yeah. Okay. Any final comments from any one of you? Marcus?
No, not really.
Your name?
None.
Not for me too.
Okay. Ryan?
No, I think that's it.
Okay. So all right. So thank you everyone for your attention. All right. So we will let our Boon Wei to wrap up our presentation tonight. Boon Wei?
Yeah, actually, thank you everyone for joining us. So hopefully, we see you in next month, and I think next month there will be a Germany meteor shower. So hopefully, we can have a clear sky in Penang and also more Germany picture in the airport. Yeah, that's all.
Yeah, the Gemini meteor observation will be on 14th of December, Wednesday night, all right, in Lim Chung Kiat Observatory in Balik Pulau, the western part of Penang Island, all right. So be there, and we hope Boon Wei will take some picture so we can in that night and record some of our voice shouting when you see the meteor coming out, record it and play in our December airport.
Okay, see you in next month. Bye-bye.
Bye.
Thank you. Bye-bye, everyone. Thank you.
Thank you, everyone.